What's up, everybody? Welcome back to Mathlete's Corner. We're going to continue talking about logarithms today, but this is level 2, so hopefully these problems are a little less straightforward. So to kick things off, we'll start with 2015 AMC 12a problem 14. And it says, what is the value of a for which 1 over log base 2 of a plus 1 over log base 3 of a plus 1 over log base 4 of a is equal to 1? And initially, this problem may be confusing because we haven't really dealt with logarithms in the denominator before. And when they are in the denominator, we normally also have another logarithm with the same base in the numerator. But here, in the numerator, we just have 1. But what we do know is we can write 1 as log base b of b, right? Because b to the power of 1 is just itself. So if we rewrite it using this substitution, we have log base 2 of 2 over log base 2 of a plus log base 3 of 3 over log base 3 of a plus log base 4 of 4 over log base 4 of a, and that should be equal to 1. And now we see that the numerator and the denominator, now they have the same base. And now we can use the property that we identified in the first video, right? So when we do that, we have log base a of 2 plus log base a of 3 plus log base a of 4 is equal to 1. Now, obviously, we can combine all of these, and we get log base a of 2 times 3 times 4, which is 24, is equal to 1. So if we convert this into exponential form, we get a to the power of 1 is 24, so obviously this means a is equal to 24. And when we go back to the question, we see that that's option D. So from this question, we learned yet another property, right? So when we have 1 over log base b of x, we can always rewrite it as log base x of b, because this 1 can be rewritten as log base b of b, and then we can use our formula. So we can keep that in mind, and then we can move on to the next question. So this is the 2021 AMC 12B problem 9, and it says, what is the value of this expression, right? So now, once again, we see that we have a logarithm in the denominator of both of these fractions, but it's not the same base as the logarithms in the numerator. As we saw in the last problem, we can just get rid of the logarithm in the denominator. So we can write log base 2 of 80, and then instead of over log base 40 of 2, we can multiply it by log base 2 of 40. And then we have minus log base 2 of 160. And instead of over log base 20 of 2, now we can write log base 2 of 20. So I guess this is a little simpler, but we are still not familiar with this form for logarithms, right? But what we do notice is we have an 80 and 60 here, 20 and 40 here. And obviously 80 times 2 is 160, and 20 times 2 is 40. So let's try using that. So we have log base 2 of 80, and instead of log base 2 of 40, we'll write it as log base 2 of 2 plus log base 2 of 20, so that we can match with the logarithm in the next term. And then with the same idea, here we can write log base 2 of 160 as log base 2 of 2 plus log base 2 of 80. And then we can multiply it by log base 2 of 20. Now what we notice here is we have this log base 2 of 2. We can actually get rid of that and replace it with 1, right? Because log base anything of itself is 1. So when we replace that with 1, we can expand it. And this first one will give log base 2 of 80 plus log base 2 of 80 times log base 2 of 20. So we can write that in. And then we subtract log base 2 of 20 plus log base 2 of 80 times log base 2 of 20. And now we see that this form is actually a lot simpler because this term here and this term here are the same. So they cancel out since we're subtracting. And now all we're left with is log base 2 of 80 minus log base 2 of 20 is equal to log base 2 of 80 over 20. And remember this property, when we subtract two logarithms with the same base, we can just divide the numbers that we are taking the log of. And obviously 80 over 20 is 4. So log base 2 of 4 is just our answer, and that is 2. So we can go back to the question, and we see that that's option D. So this question was a lot more messy than the last one, but we used the properties that we identified in the last video and in the last problem, and we found our answer. So now we can move on to the next one. So this is the 2010 AMC 12B problem 12. And it says, for what value of x is this equation satisfied? So now instead of evaluating an expression, we have to solve for an equation, solve for a variable in an equation rather. But we have 5 different logs here. They all have different bases. So this isn't exactly simple, right? So let's try to first relate this term to this term, right? We're just going to take the first two terms and try to relate them. So let's say a is equal to log base root 2 of root x, and say b is equal to log base 2 of x, right? So now when we convert these into exponential form, we get root 2 to the power of a equals root x. We get 2 to the power of b is equal to x. Now in our first equation, we have square roots, and let's just get rid of them, right? How do we get rid of square roots? Well, we square both sides, right? So we square both sides, and we get 2 to the power of a is equal to x. And that's funny because we also have 2 to the power of b equals x. So that just means that a equals b. So these two terms up here are just equal. So we could actually replace the first term with the second term. So instead of log base root 2 of root x plus log base 2 of x, we could replace it with 2 log base 2 of x. And if we do the same thing on these terms, we get the exact same result. So all of these 5 terms are actually equal. So we can actually condense all of them into 5 times log base 2 of x is equal to 40. Equal to 40. So log base 2 of x is equal to 8, and x is equal to 2 to the power of 8, which is 256. We can go back into our problem, and that is option D. And again, we found another new property from this question. So let's maybe use a different color. Log base a of b is equal to log base a to the x of b to the x. I'll put parentheses for clarity, right? And if we want to prove this, right, let's say this is equal to n. We have a to the n is equal to b. And from the second part of the equation, we have a to the nx is equal to b to the x. And this makes perfect sense because if we take a closer look at these two equations, right, if we take the first equation and we take both sides to the power of x, we get the second equation. So that exponential property actually supports this logarithmic property. So that's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next time here at Mathlete's Corner.